Greetings, Doctor. I'm Sitara Selvam, and this is my question number 3. This is the question, and this is the raw data. For the experimental design, weight and age of 10 UMS male students were collected, and for the data type, weight and age both are scale data. And his research question was, is the body weight determined by age? So from this data, I plan to do correlation to see how strongly the both variables are related. So I changed the research question to, is there a significant statistical relationship between the age of UMS male students and their body weight? So for the hypothesis construction, the null hypothesis is there is no significant statistical relationship between the age of UMS male students and their body weight. And for the alternative hypothesis, there is no significant statistical relationship between the age of UMS male students and their body weight. The alpha is set at 0.05. So first, after I got the question, I go to the Excel and put it in a table form. Student ID and their age and their weight. And then I save it in CSV. This is my data. And after that, I go to RStudio to conduct the test. So first, I set the working directory. This is my command. And second, I create the object name age and age underscore weight, and I run the test. And after that, this is my observation. And after that, I want to plot scatter plot. So I type plot and then the variable, and to complete the scatter plot, I titled it weight versus age, and for the x-axis it's age, and for the y-axis it's weight in kilogram. And after that, I conducted Shapiro test to see the normality, whether the data is normally distributed or not. So Shapiro test was conducted for both the variable age and also weight. And later on, for Levin test, I have to do a separate Excel and do it the data in this form, which is variables, age and weight, and then the measurements. So after I separate it, put it in a different Excel, and I conduct, and then my command is age underscore weight 2, and then I continue the test. After that, library car was loaded and Levin test was conducted. So for the normality test, this is the results I obtained. For age, the p-value obtained was 0.2351, which is more than the alpha value, and this indicates the data is normally distributed. While for the weight, the p-value obtained was 0.008555, which is less than the alpha value, and this indicates that the data is not normally distributed. Hence, Spearman's coefficient of correlation is used to study the relationship between the variables. While for Levin test for homogeneity of variance, the p-value obtained was 0.5917, which is more than the alpha value 0.05. So there is no significant difference in variance between samples, and variance of both samples are equal. This is the scatter plot I obtained. So as we can see, from 30 to 40 age of 30 to 40, the weight is declining, and after that until 70 it's not a consistent, and the points are all over. So overall there is no proper relationship between the weight and also age. As a conclusion, it is not a clear relationship. So as a conclusion, the null hypothesis is not rejected, hence there is no significant statistical relationship between the age of UMS male students and their body weight. That's all for me. Thank you.